Well, good afternoon, everybody, and welcome along to Data Platform Down Under. Once again, on behalf of Martin Catherall and myself, I'd like to welcome you all and thank you all for coming along to today's session for September. In this session, we've got Will Valida joining us from Microsoft, and I'll hand over to Will in just a second so that he can take us through today's session. To let you all know, this session is being recorded and will be made available on the YouTube channel once the recording has been processed, and you can come back and watch this at any point in time. For those of you who are live, feel free to ask any questions, put them in the chat window, raise your hand. I'll be monitoring those and we'll be able to get Will to answer those questions for us throughout today's session. So without holding things up, I will hand over to Will, who'll be able to introduce himself further and take us through this month's session. Thanks,
Awesome.
Will.
Thank you so much. Hey, everyone. It's great to be here. Today, we're going to be talking about deploying Azure Cosmos DB using Bicep and GitHub Actions. My name is Will Valida. I'm a customer engineer for Microsoft working in the Fast Track for Azure team based in Auckland. And we're essentially a post-sales team. So we work with customers to help modernize their applications into Azure and also help their deployments into production. And today, we're going to go through, like I said, deploying Azure Cosmos DB using Bicep and GitHub Actions. So just to take you through what we're going to be talking about in this session, first off, I'm going to define what is infrastructure as code and why we would use code to basically provision our infrastructure. Then I'll talk a little bit about what Bicep is. Some of you may have had some experience with infrastructure as code before. Don't worry if you haven't, that's not a prerequisite for this session, but I'll just explain what Bicep is and how it relates to Azure. Then I'll talk about the Azure Resource Manager itself and how we can use Bicep to interact with the Azure Resource Manager API to provision our resources into Azure. And then I'll talk a little bit about what GitHub Actions are and how we can use GitHub Actions to kind of automate our infrastructure deployments using GitHub Actions. And then we'll go through a step-by-step demo. So we'll start off by creating our repository, setting up our GitHub resources, like our environments, our workflow pipelines. Then we'll actually build out a Cosmos DB account in Bicep, and we'll build some other resources as well, such as log analytics, key vault, and we'll actually build a function app that can interact with our Cosmos DB account with a particular role assignment. And then we'll run our pipeline, see how that all works in action before finally finishing off with a bit of Q&A. So if you do have questions, pop them in the chat. I can answer questions as we go along, but Warwick, you will need to let me know when there are questions, and just feel free to interrupt me as I go along. And we'll also have time at the end for any questions. So let's start off our discussion by defining what infrastructure as code is. So essentially, you can think of infrastructure as code as kind of like an instruction manual for your infrastructure. It details the end configuration for your resources and how we're going to reach that end configuration state. So you'll define your infrastructure code and basically saying, okay, I want a Cosmos DB account. Within that account, I want a couple of databases and container. That's going to be your end configuration state. Essentially what it is, we use descriptive coding language and versioning similar to what we use for our application logic. And it's really there to just kind of describe what our end configuration state is for our infrastructure. It allows us to automate the provisioning of our infrastructure components in a way that's consistent and repeatable. And the idea is, with our infrastructure as code capabilities, we can integrate that with our current processes. So imagine you're developing an application and you're using CI/CD practices and principles in order to deploy your application. It's essentially the same concept for your infrastructure. So this allows us to kind of validate our infrastructure, test it to make sure that what we're going to deploy is what we'll actually deploy, and we can put guardrails against our deployments so we don't just deploy straight from our local computer. It's kind of that ability to shift left the responsibilities. It provides us a bit of consistency. So rather than just doing it on your local machine, you basically automate the process and reduce human error by doing that. So instead of having my Bicep templates or infrastructure as code templates on my local machine and just deploying it and being the person in my team that deploys that, we can provide some consistencies with our infrastructure deployments, so anyone within our team and organization can pick up those infrastructure templates and deploy them in a way that's consistent. We can also do some other things like code scanning, making sure that our templates are syntactically correct, that they're secure, they're not going to deploy anything that we don't want it to. We can manage secrets within our infrastructure templates. We could also implement some access controls. We don't want everybody in our organization to deploy all the things at once. We might want to use managed identities or service accounts to automate those resource provisioning. We can manage multiple environments, and we get a better management and understanding of our cloud resources. It also allows us to avoid configuration drift. So imagine you're starting out in Azure and you're provisioning a couple of services and you're not quite sure what each component does. You're not quite sure what managed identities are. You're not quite sure what kind of logging and diagnostics a particular resource admits. And over time, if you're doing stuff manually in the portal, it can be difficult to keep a track of what your particular resource is actually doing. And what infrastructure as code does, it kind of avoids that configuration drift, and it uses tooling that uses idempotent operations, meaning that it provides the same result each time we run it. So if we're provisioning a Cosmos DB account, for example, with particular logging configured for that particular account, we know that every time we deploy that template, it's going to produce the same result, rather than us going into the portal and trying to set up manually, and we might have configuration drifts between different resources. It's also coming back to this multiple environment scenario. It's great for when we're provisioning new environments. So say if we want to spin up a prod-like environment into like an integration test environment, we can actually use infrastructure as code templates to do that automatically for us rather than doing it manually. It's also good for managing differences between different environments. You might have your dev and test environment, a really basic bare bones environment that allows your developers to just kind of test and see what the code that they're writing, just to see how it reacts within a particular Azure environment. But for your production environments, you might want to lock that down. You might want to provision higher SKUs because only some resources provide availability zones, for example, at a higher SKU level than other SKU levels. So you want to manage those differences between those environments. That's also great for disaster recovery as well. So in the worst case scenario, if a region goes down and all your resources are lost, rather than having to provision everything manually, using infrastructure as code, using those templates actually allows us to kind of stand up those environments as they were when before this the region went down. So let's move on to what the Azure Resource Manager is. So essentially, the Azure Resource Manager is a service used to deploy and manage resources in Azure. Essentially, it allows us to create, update, and delete resources within our Azure subscription. And we interact with the Resource Manager using ARM or Bicep templates. You can really think of the Azure Resource Manager as kind of like an API. And we use different languages such as Bicep, PowerShell, ARM templates, etc., to kind of interact with the Azure Resource Manager. And through there, we can actually create our Azure resources such as web apps and Cosmos DB accounts and SQL databases. This provides us with another number of benefits, so we can actually manage our resources as a group. It gives us that ability to manage our infrastructure through templates, and we can redeploy our solutions throughout our development lifecycle and have confidence that the resources that we deploy are consistent. So let's move on to actually what Bicep is. So Bicep is a domain-specific language for deploying Azure resources, and we use it to create resource manager templates. All resource types, all API versions that you would use in ARM are valid in Bicep today. And Bicep provides a much simpler and nicer syntax for writing templates. I originally I've come from a Terraform background. So when I'm writing infrastructure as code, I'm expecting to write it as I would with any code. Just taking my Microsoft hat off for a second, I avoided ARM quite strongly because I didn't want to spend my time writing JSON. As a developer, I like working with JSON in my responses, but I don't want to actually spend time writing JSON files to provision my infrastructure. So Bicep essentially is an evolution because it provides a much nicer and simpler syntax for me to write those templates to provision stuff to Azure. You can actually break down complex template deployments into modules. There's this idea now that with Bicep, we can write more modular code and then reference them within our main Bicep files. And one of the advantages of using modular code is we can actually share these modules within our team using a container registry like Azure Container Registry. So say if you're working on, say if you're building a microservices architecture throughout your organization, and there's a specific way you need to configure, say, an Azure function. What you can do is you can write a module for that Azure function, share that module using Azure Container Registry, so other members throughout your organization, provided they have the permissions to, can use those modules within those templates rather than having to rewrite those modules from scratch, which gives that real nice shareability between your organization, and it speeds up your development time. Bicep also has the advantage over ARM where it automatically detects dependencies between your resources, removing some of the tedious work involved in template authoring. I remember the very brief work that I did in ARM back in a previous job. We had kind of like templates within templates, and what Bicep does, it actually automatically kind of detects dependencies within your resources, between your resources, sorry, and it just removes that kind of like tedious work involved in the template authoring. And also when we're developing or working with Bicep, say if we're using Visual Studio Code, it has a real nice extension for Bicep that makes writing those templates a lot easier. Essentially, part of my demo, I'll show this, but it provides great type validation and IntelliSense for resource type API definitions, which just makes authoring Bicep a lot nicer, a lot nicer experience. So how does Bicep actually work? So when we deploy resources to Azure, essentially what we do is we write up our Bicep template and we submit that template to the resource manager. Now, because essentially you can think of it as just an API call, and that API call still requires a JSON template. So what Bicep does is it has tooling that converts your Bicep template into a JSON template. And this is known as transpilation, which is essentially the process of converting your Bicep source code written in Bicep into another language. So in our case, writing it into a JSON template. Now, both the Azure CLI and Azure PowerShell have built-in support for Bicep, and this uses the same commands to deploy our Bicep and JSON templates. So there's not like a discrepancy, or sorry, differences between, say, like a Bicep command and an ARM command. You're not there going AZ ARM, or there are AZ Bicep commands, but when you're deploying it, it uses the same kind of same commands to deploy your Bicep and JSON templates. And then once we submit a deployment, the resource manager looks at what's already deployed in Azure and then looks at what you're trying to deploy within your Bicep template, and it will set up a sequence of steps to achieve this, achieve your desired end state by invoking the resource manager API. So that's kind of a quick kind of like overview of what Bicep is and how it works. We will now switch our attention to GitHub Actions. So essentially what we can do with GitHub Actions is we can automate our Bicep deployments using a workflow. And this helps us to kind of define the steps within our deployments and essentially automate them. And when it comes to working with Bicep code, we can actually use our workflow to perform a number of steps within our pipeline. So we can use it to verify our Bicep code. We can use it to test it. We can use commands to preview it. So essentially, before we actually deploy it, we can see what's going to be deployed as part of that pipeline. And then we can also use workflows to then automate the process of deploying our resources. Now, when we define our workflow configurations, we define them using a YAML file. This file is stored alongside your Bicep code and within your Git repository. And this will make a lot more sense when I'm actually doing the demo. But you can think of workflows are really made up of several components. So essentially, first off, you have your runners. And these are computers that are configured to run deployment steps for a workflow. And with these runners, they can be self-hosted or they can be hosted by GitHub, and they will have the tools needed to deploy your Bicep templates to Azure. And then within your file, you'll have triggers. And essentially, these instructs GitHub Actions when to run your code. So for example, you can manually trigger a workflow file if you want to. You can trigger a workflow flow file on a pull request. You can trigger it on when you deploy a push to a particular branch, such as main or a feature branch or a bug fix branch. These are the kind of triggers that we can use to actually kick off our GitHub Actions workflow. And then within our file, we also have steps as well. And that represents like a single operation that the workflow performs. And with using steps, we can use run steps that run, say, a single or sequence of commands using Bash, PowerShell, or the command shell. And we can also use action steps, which there's a big marketplace of kind of pre-built actions that you can use within your workflow file that are really great for when you don't want to write script statements within your workflow file. I'm of the opinion that if you're writing a particular script, you would have to, if you're writing a script, it's best to reference that in a file of that particular script type. So say within my workflow file, I've got a PowerShell script that I want to execute. I would write that within a PowerShell script rather than writing inline scripts within my workflow file. If you're doing simple commands, it's okay. You can it's perfectly fine. But if you've got complicated scripts as part of your deployment process, it's best to put that in another file. Or if you don't want to write scripts at all, you can use action steps as well. And then finally, there are jobs, and this represents an ordered set of steps. Now, in your workflow files, you'll have at least one job, but in complex deployments, it's common to have more than one job, and we'll see this in action within the demo. Now, when it comes to deploying our GitHub templates via GitHub Actions, sorry, our Bicep templates via GitHub Actions, and this is where we're going to turn our attention to the demo. Essentially, we can think of this of several steps. So, So essentially, what we'll need to do, we'll need to set up a service principal that will enable the pipeline to deploy stuff to Azure. We'll need to give it a particular role assignment, and we're going to use the AZ-CLI to do this. Then what we'll do is we'll write our Bicep code. We'll create our Cosmos DB account with all the various different resources. And then when we build up our workflow file, I want to be able to validate my Bicep code to make sure that syntactically it looks correct, and make sure that there's that there's no problems with my Bicep code. I'll be creating secrets that I'll be using within my GitHub Action workflow file, particularly when I need to authenticate to Azure, and I'll show you how we can do that using GitHub. We'll then want to, once we've validated our code, we want to preview the changes that we're going to make to our Azure environment. So we want to be able to have a step where we review what's going to be deployed and have a way to either approve or reject that deployment. And then finally, we're going to be deploying our resources to Azure itself. Cool. So we'll kick off into the demo. So what I'm going to do is I'm first going to create a new repository. So we're just going to call this Cosmos Bicep GitHub Actions. That's available. I'm going to make this public. I'll add a README. I don't necessarily need a git ignore template, but I always like to put one anyway, and I'll create an MIT license for it. Now, for this demo, I'm going to keep this really, really simple. I'm just going to have a main branch, but obviously when you're developing code for your organizations, please use different branches and only create pull requests to go to main. do it that way. So what I'm going to do is just clone that repository. Hopefully that won't take too long. And I'll just cd into that and open up Visual Studio Code. Make sure that window opens the one I'm sharing. Cool. So here's my repository from before that I've just created. So now I'm going to create a main.bicep file. And if I just go into extensions and I just search up Bicep, this is the extension that you want to install. So this will essentially provide you this IntelliSense and type validations that you need to use throughout your file when you're writing your Bicep code. Cool. So first thing first, I'm going to define some parameters. And essentially, when we're working with our Bicep code, particularly if we're deploying our Bicep code to various different environments, we might have different naming conventions for different environments. We might have different regions that we're deploying to. We might have different consistency levels, etc. So what I'm going to do is I'm just going to copy and paste this. What I'm doing is I'm copy and pasting a location. I'm just going to get more real estate there. And I'm going to just copy and paste an application name. And these parameters, essentially with parameters in Bicep, you can either set the value, hard code the value within your Bicep template. We can have something called a parameters file. So those of you who are familiar with ARM templates, if you're deploying to multiple different environments, you might have different parameter files for different environments, one for your dev, test, production environments. So you can pass parameters to your template that way. And then finally, you can deploy parameters via the CLI. So there are kind of again, parameters where you can actually pass your parameters through if you're deploying your Bicep templates via CLI. But for this one, we're just going to provide these hard-coded within our template. And then I'm going to add another parameter for my Cosmos DB account. And you might notice these different annotations that I'm applying here. So essentially, some resources in Azure will have particular requirements for naming, like how long a name can be for a particular resource, how short it can be, etc. And this is just saying, okay, the maximum length that this parameter name can have is 44 characters. And the idea about Bicep as well, and infrastructure and code is general, we essentially want to codify our infrastructure templates and make them reshareable in such a way that anyone with any kind of experience, doesn't matter if they've been a developer for 20 years or they're encountering infrastructure as code for the first time, they want to be able to understand what our what our parameters is doing, what their purposes of that parameter is. So here we're providing a bit of a description for what we can do with our Cosmos DB account. And we can also do stuff like allowed values as well. So here I'm copying and pasting the consistency level as well. So here in Cosmos DB, for those of you who don't know, it has 5 defined levels of consistency that have got particular values. And I'm saying that only these values are allowed. So eventual, consistent, prefix, etc., etc. I'm setting it to session as well. But if someone was to pick up this template and try to provide a different value, it would fail on the validation stage because I haven't provided one of these allowed values. Cool. And we can work with different types as well. So we're working with a lot of strings here, but I'm just going to paste a couple working with Boolean values. And then I'm just going to show another example of what a minimum and maximum value can do as well. So here I've got one for throughput. Essentially, this is really handy, particularly in Cosmos DB, where if you're provisioning something that's going to be charged, you don't want someone who doesn't really understand how, say, throughput works in Cosmos DB just to provision a container with 1 million request units. Otherwise, you're going to get broke very quickly. So here's just another step, another action. Or another way, sorry, that we can define the minimum and maximum value that we can provide for a particular parameter. Cool. So I'm going to copy and paste the rest of the parameters. And I'm also going to show you a variable. So within Bicep templates, we can define parameters, and these are values that we can pass through to our template when we're deploying them, or we can set up variables as well. So here I'm just creating a variable for tags. But if I wanted to pass this through, I could pass through tags as a parameter, as an object. But you have the option of making stuff configurable via parameters, or keeping stuff consistent, or enforcing stuff through variables. The idea is your parameters should be flexible enough in a way that you can change the values across various different environments. They're understandable across your team members, but you may not want to put lots and lots of parameters just to make it simpler and straightforward to use. It really does depend on your use case. So now what we're going to do is we're going to create our Cosmos DB account, and this is essentially what we call a resource. So here I'm going to create a resource using the resource key, and I'm giving it a symbolic name, Cosmos DB account, and then I'm going to give it the type. So that's living in the Microsoft document DB database accounts. And see how the IntelliSense is making this easier for me to write. I've also got Copilot on here as well, but that's a discussion for another time. And here I'm just using the parameters and variables that I've defined earlier to build up my Cosmos DB account. So I've got a location for my account within the properties. Essentially, when it comes to populating your resources, what the IntelliSense does, or what the extension does, it essentially provides all the compulsory or the required parameters that you need to provide for your resources. So there was a IntelliSense earlier. Let me just copy and paste this. IntelliSense earlier that kind of said, okay, give me all the required properties for this, and it will essentially fill that out for you. So let me just copy and paste this, just to save a bit of time. So here on my Cosmos DB account, we're enabling, we've got our a name for our account that we've defined earlier. This is just going to be a normal SQL API account. I'm applying some tags on it for when it was last deployed. I've got a location, all different properties as well. So I'm defining my backup policies, consistency levels, regions as well. Oh, I haven't defined a parameter for secondary region. Let me copy and paste that. Come back down, and I'm enabling system identity. And what we can do with using our Bicep template, we can essentially add child resources using different resources as well. So instead of having to do this string interpolation, which I just dislike, I'm going to put database name, and then I'm going to define a parent resource with Cosmos DB account. Now, what's that? APIs, that's not the right one. That's okay. Database accounts, SQL databases. There we go. That's the right one. Cool. DB. Why is that giving me? It's missing properties. Anyway, we don't actually need this depends on. So I've got this underscore here. We don't actually need to do that anymore in Bicep because Bicep automatically detects the dependencies for us. So for here, I'm just going to give the properties, and then you see this required properties here. So rather than having to type all of this out, I just press tab, and there it is. There's my database name. And then I'm going to create my container as well. Now there's quite a bit to this, but essentially, I'll just copy and paste that as well. But do you see how this is all kind of forming up together? So the parent of that is my database that I've defined. So that's a child resource of my database, and then my database is a child resource of my Cosmos and DB account. And one of the cool things that Visual Studio Code has, if I just click that, that opens up a Bicep visualizer. So if I just save that. So you can see as I'm writing my Bicep code, I'm seeing the dependencies that are being created between my different resources. So in using ARM templates, we'd have to write depends on and say, okay, this container depends on this database, and then this database contains on Cosmos DB. With Bicep, we don't need to do that. We've already defined that through parents, and then that's that parent property, and then that's actually Bicep has gone ahead and figured out, okay, what are the dependencies between my different resources, which is really cool. Cool. So now we'll talk a little bit about extension resources. So within your various kind of like ARM namespaces, there are particular resources that you can create within the scope of that resource. But here, what I'm going to do is I'm going to create diagnostic logs for my Cosmos DB account. And this is essentially what we call a extension resource. So I haven't created my log analytics workspace yet, and I'll show that through a module in a second. But essentially what we're doing is this resource, let me get some real estate here. This resource, it still lives within its own ARM namespace, but we're defining it to the scope of our Cosmos DB account. Now, using what we call extension resources within our Bicep code, we can apply this type of resource to other types of Azure resources. So this is not just applicable to Cosmos DB accounts. This is applicable to app service, function apps, SQL databases, etc. The only differences that you might find are what kind of logs a particular resource will emit and what kind of metrics as well. So these metrics and logs are very specific to what Cosmos DB provides, but the resource can be applied to any type of resource. So since it's complaining about this log analytics workspace, what I'm going to do is I'm going to create a new folder called modules, and I'll show you all how modules work. So here I'm going to create a module log analytics .bicep. This is just another Bicep file. And then within here, I'm just going to copy and paste this. And here what I've done, again, I've provided parameters, which are now parameters to a module, not a Bicep template, and I'll show you how that works in a bit. And here's the resource that I'm defining as well. So now if I'm using several log analytics workspaces as an example throughout my Bicep template, I can just call this resource. And here I'm defining an output. So with modules, we actually have the ability to generate outputs that a particular module will emit. So if you look at our Bicep code here, you see that this workspace ID is an output of this module that I'm going to create. So if I go back into my main Bicep template, I just find my log analytics workspace module. Actually, I'll type this out. So what I'm going to do, instead of naming it as a resource, I'm going to go module log analytics workspace. Make sure I spell that right. And here I'm going to use modules, and there's my log analytics module already. So instead of defining a resource type here, Microsoft Insights diagnostics, for example, here I'm just referencing a module. So what I'll do is hopefully get Copilot leaves me alone. I don't think it's going to, but I'll just do that to save a bit of time. And I'll remove tags because I don't need tags for this one. But essentially these parameters here that I've defined in my modules Bicep code, I'm now providing into my module. So the parameters that I've defined within this template, I'm providing as an input into my log analytics workspace module. And then here I'm saying, okay, the workspace ID, that output that I've created for this particular module, that's the actual workspace resource ID, I can now use that as an output for my workspace ID within my diagnostic logs. So it gives you a way to kind of protect and expose various different outputs that your resources will admit. One thing I will note here, I could admit something like connection strings or customer keys as part of outputs. That is possible within Bicep. It's generally not recommended. The recommended practice, just looking at the time, I won't go into this as today, but I have got a sample which I'll share with all of you. The practice is to, when you're working with secrets such as connection strings, save them to Key Vault, store them as secrets or as keys in Key Vault. And then what Bicep has, it has a module, a function that allows you to reference Key Vault secrets within your Bicep templates. You do need to enable your Key Vaults to be authorized for template deployment. That is a prerequisite to using Key Vault secrets within your Bicep templates, but that's generally the recommended practice that we advise. Cool, so what I'm going to do is I'm just going to go back into here. Well, before I do that, make sure everything is saved. It does look like it. Just going to go git status, going to add. I'm just going to commit to main first, commit. I'm going to push that up. Hopefully that's all good. And then I'm going to go back into my repository, refresh that. And now we're going to start the process of setting up our GitHub's Actions workflow file. So first things first, what I need to do is I'll need to go into settings and I want to create an environment. And the reason why I'm creating this environment is I want to be able to manually approve my deployments before I actually deploy my Bicep templates. I want to be able to view what's the preview, what's going to be deployed before I actually do that. So there in my environments, I've created a environment called production. I'm going to add a required reviewer. I'm just going to add myself, but if you're working within a team, you might want to add multiple reviewers. You can also set timers on your deployments before allowing them to proceed. And you can also limit what kind of branches can actually deploy to a particular environment. And you can also set secrets at the environment level as well. But here we're just going to keep it simple by adding a required viewer. So I'm going to save my protection rules. And now what I'm going to do is I'm going to set up some secrets. So I'm going to need to do, I'm going to need two secrets. I'm going to need some Azure credentials. I'm going to need a resource group as well. But I haven't actually created a resource group yet. So what I'll do, I'll actually CLS that. And I'm going to go AZ group create. I'm going to give it a name of Cosmos Bicep V2 RG, because I was testing this before. And we're going to deploy in Sydney. So location Australia East. This is going to create a resource group that I'm going to be able to use. Cool. So now that I've done that, what I need to do is we need to generate some deployment credentials. The GitHub action that we use for our deployment needs to run under an identity. And what we can do using the Azure CLI is essentially create a service principal for that identity. So what I'm going to do is going to go AZ AD SP. So Azure AD service principal. I'm going to create an RBAC role, or create for RBAC. I'm going to give it a name. So I'm just going to use Cosmos Bicep V2 SP. And I'm going to give it a role. Now, a general good practice for when you're creating service principals is to only give it the least privileges possible. So we need to give it a role that's sufficient enough for it to do it, for the service principal to do their job. So here I'm going to give it a contributor role because I'm contributing resources to a particular resource group. And then I'm going to give it a scope under the scope of that resource group. So essentially with this service principal, it's only going to be able to execute or contribute to this resource group alone. It won't be able to contribute to another resource group. So I'm just going to type resource groups, and I'm going to go give it the name Cosmos Bicep v2-rg. And then finally, in order to generate the credentials, I'm going to go -- SDK auth. Enter. That will be depreciated in a future release, but I'm not sure what the future command is going forward. The request did not have a subscription or valid. Okay, let me make sure I've got that right. I missed the word subscriptions. Missing an S there. Creating contributor. Cool. So here it's generated some credentials that I'm going to use. So I'm just going to copy and paste that. And I'm going to create a new repository secret. I'm going to call this secret Azure credentials, as I've done before, as you can probably see. And I'm going to add that secret. And then I'm going to add a new secret for my resource group. And I'm just going to call it, what did I call my, just get my resource group name there and add that as a secret. So I'm going to add that. Cool. So those are my two Azure credentials. Two secrets that I'm going to use within my GitHub Actions workflow file. So in order to create my GitHub Actions workflow file, I go to my repository under Actions. I'm going to skip this instead of workflow myself. There are some pre-built ones that you can use, but I like to kind of build mine from scratch, so I have a full understanding what that pipeline is actually going to be doing. And I'm just going to create a YAML file called deploy. I'm just going to commit that. And then I'm just going to git pull and bring it into Visual Studio Code. Cool. So here, so there's my GitHub Actions workflow file. So within my GitHub Actions workflow file, what we're going to do is we are going to run a Bicep linter to make sure our code looks good. We're going to validate our code. We're going to generate a preview of that code. And then we're going to deploy it using our production environment as kind of like a guardrail before we actually deploy it. So I'm just going to get rid of all of this. Essentially, get some real estate going as well. I'm going to give it a name. And that's going to be deploy my Cosmos DB account. And then in order to trigger this, we're going to need to define a trigger. So we use the word on. And we can run it on a variety of different triggers. So we can do it on a particular branch if we wanted to. We can do it on particular branches, pull requests as well. But for now, I'm just going to use workflow dispatch, which is essentially say, OK, this is a manual trigger. Then I'm going to define my jobs. So first things first, I'm going to define my lint and validate job. And this will show you the difference between kind of run steps and also action steps. So here, why is that complaining? It should be fine. We'll run it and see how it works. OK, so here within my lint job, we're defining what it's going to run on. So it's going to run a Ubuntu runner. And these are the steps that it's going to take within this lint step. So essentially, we're going to just check out our repository, and then we're going to run this script against it. So we're going to build the file and make sure it looks all good. So this is what we call a run step. And then within our validate step, what we're doing is we're validating our Bicep code. And essentially, this needs parameter here says, OK, before you run this job, you need to make sure that lint passes. And this is a nice way of making sure that your jobs don't all run in parallel, and it ensures that your jobs run in the sequence that you want it to. So within this validate, essentially, we've got some steps where we're going to sign into Azure, and those Azure credentials that I saved earlier, I've saved that as a secret. So I'm going to use that secret using my Azure credentials. And then from here, I'm going to run my pre-flight validation step. And essentially, this is just going to validate my Bicep template. And as you can see here, this is what we call an action step. So someone has gone ahead, probably the ARM team, have gone ahead and built this action that you can use without having to write this as a script within your workflow file. You can validate your Bicep code using the AZ CLI, but this is a nice way of using an action instead. We're going to do pretty much the same thing for our preview step as well. So once we validated our code, we need to preview it. Did I actually save that? Let me try that again. Apologies. I think I've also got the indenting wrong. Live demos are always fun. Yeah, so essentially once we validated our code, we want to preview our code to make sure that what we're deploying to our Azure environment is actually what we intend it to deploy. And we can do that using the what if command. So here I'm running a inline script saying, okay, what if I deployed this this template using this template file here, which we can find in under, there's our main Bicep file. So what I'll do is I'll actually just delete that, just make sure that makes sense throughout. I usually put it in a deploy folder if I'm deploying both infrastructure and code. So I kind of split them up, but here we've just got a main Bicep file, so that's okay. Cool, so we've previewed that and we need the lint and the validate stages to pass. And then finally, once we've done our preview stage, we're going to deploy our infrastructure. So here we define another job. Make sure the indenting is right on this. Yeah, we're going to deploy our infrastructure. And essentially what I've done here is I've provided a parameter called environment, which is going to take that production environment. And essentially it's going to wait for us to manually approve our deployment before the deployment stage actually kicks off. And it needs this preview stage to be successful. So there we're just introducing a couple of guardrails to ensure that we're not just deploying our template right when we push it or when we trigger the workflow. We've actually got some guardrails to kind of control our deployments to our different environments. Awesome. So there is my workflow file all ready to go. So what I'm going to do is I'm going to just add my deployment file, commit it, deploy file, and I'm going to push that. And then what I'm going to do is go back into GitHub Actions. Click on my deployed Cosmos DB account. This is the name that we've given our workflow file. And I'm going to run this workflow and let's see how it goes. So essentially, in a little bit, it will see my deployment running. And here, because we've defined our steps, if I just zoom in a little bit and I'll drag across as we go, we can see that because we've added our steps as dependencies of each other, we see that they'll kick off in the sequence that we've defined it. So here I've said, okay, this validate stage needs this lint stage to pass before it starts. And it will do the same for when we preview our code and deploy our infrastructure. And we can actually dive a little bit deeper into this as well. So if I click into validate, I can actually see the jobs run as we're going along. So there's a lot of parameters that I haven't used, but that's okay. Cool, so my validate stage is passed. So now I go into preview. So those of you coming from an Azure DevOps background, this might look very familiar to you as if you're running your pipelines, running your deployment jobs through Azure pipelines. This is a very similar experience I found. But what I like about GitHub Actions, it's a little bit easier to get started because all you need is a GitHub account. Essentially, that's going to run my what if command. And now this is going to essentially generate a plan of what's going to be deployed to my Azure environment. So this will include what's going to be created, has anything been modified, are we going to be deleting anything, etc. And this will generate kind of like a plan of what's going to be changed within our resource group. For those of you who have worked with something like Terraform before, this is very similar to a Terraform plan. So I just let that do its thing. One thing I do want to do, I just go back into my subscription, just make sure, yeah, there's my resource group already. So this might take a little bit of time, but that's okay. So here we can see, before I kick off the deployment phase, we can see that a plan has kind of been generated. So essentially, it can do some false positives, so you do need to bear that in mind. But essentially, it will say what the plan will do. It will say, okay, the resources and property changes are going to be indicated with particular symbols. We're just creating stuff, so we've only got create. And it says it's okay, it's going to, at this scope, so of the subscription at the resource group, we're going to create a new database account. These are all the properties that we've set. We are also going to be creating some diagnostic settings that we defined earlier. Come down, those are all the diagnostic metrics and logs that I've defined. We've also got a database that we're creating as well. So my orders database, also my containers as well. So there's the throughput that I provisioned earlier. And this is part of my module as well. So I defined a module for my log analytics workspace. And it says, okay, it's going to create 5 resources for me. This will obviously change as your Bicep template grows over time. So you'll be creating new stuff, you'll be modifying new stuff, etc. But what that's done, essentially now the deployment stage is ready to go. So it needs approval. Because we've added that guardrail in there, it says, okay, I need approval before we start deploying these changes. So this will send an email to my personal account, but you can configure this, say if you've got a GitHub account that's associated with your work account, you can send it to that reviewer as well. Everything looks good, so I'm just going to approve and deploy that. And just wait for that to kick off. This will take a little bit of time, so what I'm going to do in the interim, that's setting up the job, it's downloading all the actions, is something that I've made earlier. So if I go into, yeah, this one. So I'm just going to drag that here. So here in my Bicep template, there's a lot more going on. So essentially what I've got, if I just delete all of this for now, get rid of the README. So in my main.bicep file, I've got a bunch of resources that I've defined. So I've got my container, my database, diagnostic logs, as we saw before. I've also got Defender for Cloud. Again, this is kind of an extension resource because we're defining it as this at the scope of our Cosmos DB account. I've got a module for my key vault. If I actually go into the key vault there, you can see I'm passing through a Cosmos DB account name as a parameter. And what I can do with that is, if I open up this Bicep file for my key vault, essentially what we can do is we can work with existing resources to find in Bicep as well. So here I've got a resource block for a Cosmos DB account, but I've put that keyword existing there to say, okay, this account or resource already exists. Don't go and create a new one for me. And then within my key vault, again, I've enabled it for deployment, meaning I can reference secrets in my Bicep template. I can get secrets that are stored in my key vault and pull those into my Bicep template. And thanks to bringing in my Cosmos DB account as an existing resource, I can then use it to save secrets to Key Vault. So here, without creating a new Cosmos DB account, I can get the existing Key Vault and store my connection strings in there, my primary keys, my secondary keys, etc. What else can I show you? Oh yeah, for role assignments as well. I'm a big fan of using managed identities for different services to authenticate to different services. There we can provide like a granular role assignment and permissions, well, kind of like RBAC controls, sorry, to particular resources over another. So here, for this is an example of a function app who has got kind of like a read-write role over my Cosmos DB account. Here I've defined some data actions and some role assignment IDs. Here I'm bringing in my existing Cosmos DB account as an existing resource. Let me get some real estate going. And then I'm defining it, my SQL role definition. So Cosmos DB has kind of like its own namespaces for role assignments. These differ from service to service, so do keep that in mind. So there's my role definition. And then this is the role assignment that I'm providing as well. So that's kind of, it's another extension resource, but I'm applying it to my function app over the scope of my Cosmos DB account here. So here's my role definition ID, which I've defined up here. So I've given it some action assignable scopes and permissions, and I'm saying, okay, this is going to apply for this function over this Cosmos DB account. So if I go into my main.bicep file and just find that role assignment, there it is. So there again, as a module, I'm essentially providing a SQL role assignment for that function app. So if I go back into, that's failed. Why has that failed? Did not read the path. Okay. So I forgot a main.bicep somewhere. That's okay. Essentially, what I'll do for time, I will just delete that. Live demos are so fun. Git status, I'll just git add. World's most descriptive commit message. Push that again. I'll just kick off that action again. I won't make you watch for it again, but what I will do is show you what kind of like the complete sample is doing. So I just open that up in the interim. If I go into Cosmos Bicep resource group, these are all the resources that I've deployed earlier. And if I just go into my key vault, actually no, key vault's not a good example. If I go into actually no, if I go into my Cosmos DB account, you can see there's my account provisioned, the essentials, there's my containers, my database. If I go down into my kind of like logs or my metrics, apologies, I can see that diagnostic settings. Don't want to enable that now. I can see that my diagnostic logs that I've defined in my Bicep code is sending diagnostic logs to my log analytics workspace. And these are all the logs that I've set up earlier. Cool. So what I'll do is I'll just wrap up the presentation just because of time. So what infrastructure as code does, it provides us a way to kind of automate our processes, automate the process of deploying our resources to our Azure environment that's consistent and provides us with more confidence. Bicep itself provides a simple syntax for us to author our templates to deploy our Azure resources. It is a massive evolution, I feel, particularly coming from a Terraform background, using something like Bicep to provision your your Azure resources over something like ARM templates, which was essentially JSON, which was a very complicated and very kind of manual way of provisioning your authoring your templates to provision resources to Azure. And then what GitHub Actions does, it kind of shifts the responsibility from us as human developers working on our local machines. It shifts that responsibility of deploying our infrastructure to machines to deploy our Azure resources in a way that allows us to automate and control our deployments, providing greater confidence and security for our infrastructure deployments. So that's the end of my presentation. If there are any questions, feel free to come off mute and ask. Otherwise, thanks for listening.
That's all right.
Warwick, you're on mute.
Yeah.
But Praveen has a question, so.
There we go. Thank you, Will. That was a fantastic session. I do see that Praveen has a question. Before we bring Praveen off of mute, with the session that you have taken us through, now I know the title was around deploying Cosmos DB using Bicep and GitHub Actions, but realistically, Cosmos DB is just a resource that you've used in the process using Bicep and GitHub Actions, and you could apply this to any kind of resource that you might want to be working on and provisioning and managing and maintaining in your Azure environment, correct?
Yes, pretty much. Yeah, so this is just like a very small example of provisioning a Cosmos DB account. It's kind of straightforward, and this is a very simplistic Cosmos DB deployment, but you can apply this to any kind of resource, whether it's app services, SQL, Redis caches, service bus. Again, it's using Bicep to interact with the Azure Resource Manager to deploy your Azure resources.
Praveen, do you want to come off of mute and ask Will your question?
So, all right. Thanks, Will. I think having a live demo work is quite a challenge, and I think you've managed to get that thanks to the demo gods. My
Yes.
questions basically around, like in Terraform, you have the option of like ignore settings. I'm just wondering, I'm pretty sure it's there, but just double checking. If, like, for example, we provision a container and then we've got scale settings sitting outside the initial provisioning piece. So we tend to, even in our Terraform code, we tend to ignore it on redeploy. So we've got scales usually sitting outside except for the initial deployment. Is there a similar provisioning in Bicep as well to ignore certain kinds of settings?
Sorry, so ignore, say if you've got like scale settings set up already, just to ignore that during the deployment?
Yeah, like the initial deployment, say we set up the minimal 1000 RUs on auto scale, and then after which we kind of have during its life cycle scale up and down. But any change going forward, we don't want that RU setting to come down to 1000 during a deployment itself. So we use basically any index change, any container. Yes, that changes during deployment, but not the scale itself.
I'm not quite sure actually, because the way you provision throughput is attached to the resource. So I'm not sure if you have the ability to just kind of ignore a particular property within a resource. I'll have to double check that. If you've deployed it for the first time and set it at 1000, say if it's like an auto scale one and the max one is say 1000, but you don't change the value of that property, and you've changed values of other property, it won't change. So if you keep it consistent, it will stay consistent, but I'm not sure if you have the ability to ignore a particular setting within your Bicep deployments. I'll have to double check that. That's interesting.
All right, thanks. Did have one more. Joined me the presentation half. I'm not sure if you've already walked through this, but apologies if you did. A couple of things you've pointed out there in terms of the role assignment and the Cloud Defender. So these are not part of the Cosmos ARM template themselves.
No.
So was that the extension resource? Is that, if I want to know more about it, like what's the topic I need to be reading up on?
So really, you can just think of it as, again, I use the term extension resources because they are resources that sit within their own namespaces, but essentially you apply it to another resource. So if I take that role assignment, for example, you see this scope property here.
Yeah.
I'm essentially saying, okay, this is going to have the scope over the Cosmos DB account ID that I assign. And that's how we essentially saying, okay, here's my Cosmos DB account, and I'm extending a resource. So I'm extending that role assignment resource to exist, and then I'm granting it to this function app here. So another good way of having a look at it, if I go into my main Bicep file and see the visualizer again, hopefully this generates. There is stuff to display, don't lie to me, internet. Slightly laggy, but essentially what I'm trying to demonstrate here is all of, we go here. So that SQL role assignment has that kind of scope over the Cosmos DB account. And then we're applying that role assignment to the function app. So essentially we're extending our Cosmos DB account to create a new role, which is why we call it an extension resource.
Okay. So then essentially I can have all of the code in one place in terms of be it Cloud Defender. Okay, that's great.
Pretty much. So where you can, I like to opt for modules, particularly if you're going to be sharing those particular resources. Even between different resources itself. So say if I've got multiple function apps, rather than having to write all of this Bicep code, particularly this Bicep code, having to repeat that over and over again for different function apps, I can just call a module. Can call this module to say, okay, this function app will have, or I can even use different types of parameters as well as inputs to modules as well. So that's why I'm a big fan of modules, because it does make your Bicep code a little bit more flexible.
Okay, great. Thanks, Will.
No worries.
So, Will, you mentioned at the start that your background, you came from using Terraform, and that you stayed away from using ARM. And now that you've gone straight from Terraform basically to Bicep. If somebody was used to using ARM, is there an easy way for them to be able to quickly learn or even change some of their ARM templates to incorporate Bicep?
There is a particular AZ-CLI command that you can use. So if I go, hopefully, so convert, you can actually convert your existing ARM templates to Bicep. Let me get the actual command. And essentially what it does, this AZ decompile, it takes your JSON template and then converts it into Bicep code. Now, it's not a fail-safe kind of solution. There are some conversion issues that you might, so say if you're going for your template, there might be some different values that you're expecting, or some things haven't quite converted correctly. But it's just a nice way of saying, okay, here's my ARM templates. I want to start using Bicep again. I want to start using Bicep. I'm just going to decompile my ARM code into the Bicep code. And that's a real simple way of getting started. But there is a bit of a manual kind of validation process involved just to make sure that your code is up to date.
Excellent. I see Martin has his hand up. Just before Martin asks his question, given with what you've just said that there is some work, if somebody has a lot of templates that they're working on, can they do like a hybrid approach and from inside of their Bicep templates make calls out to some of their ARM templates without actually making changes, or do they have to go through that work to make those changes and convert them from ARM to Bicep?
In that case, they would have to change it from ARM to Bicep. But in that case, if you do have dependencies within your templates, kind of try and break down that conversion into little pieces. So say if you've got an ARM template that covers a microservice, which has a function app, a database, and a message, it creates a queue as well as part of that service. It's probably best to tackle that ARM template rather than going going through various different resources and various different dependencies. So start off with your simplest ARM templates first, and then just kind of try and break up the process as you go along.
Excellent, thank you. Martin.
All right, Will, how are you?
I'm good. How are you?
Yeah, not bad, mate, not bad. I don't really have a question. It's more of a talking point than anything else. So I see where you're going through the PowerShell there. You're basically using a command line for Git.
Yeah.
Yeah. So I have not got into using the command line for Git. I tend to, I don't know, favor one tool. Do you always use the command line, or would you favor one particular tool, or yeah, I don't know, what's your view on that sort of thing?
I'm a self-taught programmer, so I taught myself how to use the Git commands. It's kind of like one of those last, I don't know, it's kind of like a badge of honor that I've been able to figure out how to use Git on the command line. One thing I do use though from time to time for very simple changes in Visual Studio Code is the source control tool here. So here, if I've got any files that I've changed, so say if I delete that comment and save that, that's just going to show up, hopefully, given the lag, but essentially the file will show up here and I can commit and add a message there. It's as if I was running git add, then git commit, and I can use the tools here to actually deploy stuff. Oh, right. Sorry, commit my files.
Yeah, so some of the more, like, I don't know, more general things, like rather than add and pull and all that, things like, you know, merging and getting rid of branches and seeing who checked in. Do you use the command line for that sort of thing, or?
No, I try and for the very simple stuff, I like using the command line because it's nice and quick. But for kind of merging stuff, creating pull requests, I use GitHub and use DevOps. Right, okay. Just use the GUIs for that.
No, that's cool. That's cool. It's interesting the amount of different tools and things that people favor or don't favor, or yeah. Yeah, cheers for that, Will.
No worries.
So, Will, given that you just made that comment that you know, you're a self-taught programmer and you've got your badge of honor that you've learned the command line for these tools, and you are using VS Code, I'm not sure if in VS Code it's the same as in Azure Data Studio when you're using source control here, but you have got the ability to turn on, so to assist you in learning what those Git commands are, you can, in Azure Data Studio, and you might be able to do it here in VS Code, if you click on your ellipses in Azure Data Studio, you have the option to show Git output. There you go, down the bottom in VS Code, exactly the same as in Azure Data Studio. You can enable that, and the tasks that you do can assist you in learning all of the commands that are being called. So for anybody who's wanting to learn a little bit more about Git and use the command line, here's an easy way for you, regardless whether you're using Azure Data Studio or VS Code, to assist you on your Git learning.
That's awesome. I didn't know that. That's really cool. I've learned something. Yeah, that's incredible.
Nice one, Maury. Nice one. Hey, I'm going to have to drop off. I've just got a call coming in. Thanks for your time, Will. It was great.
No worries. Thanks, Martin.
Thanks, Martin. Praveen, you've got another question. You can come off of mute and ask Will your question.
Yep. Thanks, Warwick. Just on, like you mentioned, kind of you've worked off Terraform as well. So just wondering, can you think of any pros and cons between the two? Any advantages or disadvantages in terms of using one over the other?
Particularly from an Azure perspective, one advantage that Bicep has over Terraform, I feel, is the management of state files. So when we're working with Terraform, we'll have our state files, and we usually see customers, and I've done this in the past, store those state files in blob storage accounts.
Yep.
And those blob storage accounts are essentially another resource in Azure depending on how complex your environment is, I used to work in the banking sector as my first job out of uni, and those storage accounts were locked down tight. They were stuck behind VNets, and there was all this complexity that we had to do just to try and configure a storage account to hold our state file in. It's not a massive thing. I think, you know, I wouldn't say. I think it's just nicer in Bicep that you don't have to work with state configuration files. There's not that need to do so. Whereas with Terraform, you do need that state file in order for Terraform to say, okay, here are the differences between what the desired state is and what the current state is. But with one of the things I will say about ARM in general is, by default, your deployments are incremental. So essentially what it will do, it will look at your desired state, look at your current state in Azure, and it won't necessarily delete resources that are defined in your end state Bicep file, which can be good or bad depending on what you're doing. But just coming from that Terraform background, when I'm planning my Terraform deployment, I can see, okay, these resources haven't been defined within my end state configuration. They're going to be deleted. So Terraform has that advantage over Bicep in being a little bit more explicit, in my opinion.
All right, cool. Thanks. And probably one that I probably missed at the start in terms of how Bicep goes about its deployments. Like, one of the challenges we do have is usually with the changes on Cosmos, we're restricted to doing one at a time. Like if I'm changing continuous backup and a consistency, default consistency, kind of does have to do it as two. I'm not sure if that's.
Yeah, I've totally encountered that. It's Cosmos is one of the kind of not bad examples, but one of the most prominent examples of that, where there are certain features that a particular service will have that's common across all features. Take it, for example, availability zones. You can update some resources to enable availability zones later on, or you have to enable them when you create your resources. Now with Cosmos, there are various different dependencies on like various different capabilities that it has. Just off the top of mind, I think when you're defining like multiple regions, you can't enable analytical backup. So there's different types of backups. You can't move from one backup type to another, and it's all done on creation. So it's uniform across all resources. So you do have to kind of look at the reference documentation just to see what you can do and can't do when you're defining your resources in Bicep, and then just weigh that against the kind of limitations of the product itself.
I get, like, in terms of what you're saying is like the product limitation itself, but if you were to make multiple changes at one go, sometimes we hit a blocker saying, like, if I were to change, say, add a region as well as change the backup type to continuous, sometimes it needs to be one after the other. It does not deploy together, but there's no limitation as such. Is that still the case with Bicep, or does that go
that's
away?
Because it's not a Bicep limitation. It's a resource limitation.
Oh, right. Okay, that's what you meant. Cool. Thanks, Will. Appreciate it.
No worries.
That's all I had.
Well, thank you, Praveen. Thank you for joining us. Thank you, Will, for giving up your time and spending a little bit of time with us here at Data Platform Down Under and sharing your knowledge around deploying Cosmos DB with Bicep and GitHub Actions. As I did mention at the start of this call, this session is recorded. I will process this and it will be made available on the Data Platform Down Under YouTube channel, where you can come back and rewatch this session, as I'm sure that there's lots that you didn't pick up first time of all of the great content that Will has provided us today. With that, thank you, everybody. Thank you, Will. Enjoy the rest of your day. We'll see everybody else online. Thanks.
Awesome. Thank you.